So for this problem, you have a free body diagram. You have a free body diagram of the block that's sitting on the ramp, has the normal force acting perpendicularly, the tension pulling along the rope, and the force of friction opposing that upward motion, and the weight pulling straight down. It didn't ask for the free body diagram over here, but you're going to draw that the T is up and the weight of that block is down. For this problem, I'm going to treat down as the negative direction for this block, and I'm going to treat along the ramp the direction of the motion as positive here. You can solve it with different positive and negatives. That's just what I'm using. So that's really part A is 4 points, 1 point for each correctly drawn vector. For part B, it asked for the sum of the forces. Let's see if I can do this. For block A, the block that's on the table, we're going to do the sum of the forces in the x direction equals max, which will give us T up along the ramp minus F sub k, it's opposing the motion, minus,
I start with T.
You do start with T, minus Wx equals 0. Oh, just kidding, not 0, equals ma. Okay, and then the y direction for that block is the sum of the forces in the y equals may, and then you get n minus w sub y, Troy, that's not nice, equals 0.
Excuse me.
0 because there's no motion. And then the block that's falling down over here, we're just going to do the sum of the forces in the y, and we're going to get T minus WB equals negative MBA. And the negative is important because that block is moving in what I've called the negative direction. If you chose to write WB minus T equals positive MA, it's the same thing. So that's what you needed to do to get your points for that next section. And I can't remember off the top of my head right now, but I think we set a point for each of these statements. Now really we start to do the algebra. So over here, instead of WY, I'm going to write N equals WY, or N equals mg cosine 32. So over here on this side, I'm going to end up with T minus mu sub k times the normal force, and I can plug this in, minus mg sine 32 equals ma. You're going to plug in all your numbers. You know everything except for t and a, so you're going to get a simultaneous equation in terms of t and a. So just to make sure, we get T minus 0.34 times 50 times 9.8 times the sine of times the cosine of 32 minus 50 times 9.8 times the sine of 32 equals 50a. Yesterday when kids were working on this, one mistake I saw often was that they subtracted these two, which is fine if you subtract both of them, but these are both negative values, so you should get a bigger negative value when you combine the two terms. Now up here, this one looks fairly easy compared to that one. You get T minus 100 times 9.8, which is 980, equals negative 100a. So now you have two simultaneous equations. I would solve for T, so you get like 980 minus 100a, and then take that and substitute in over here. Okay. Without showing you all the work, if you do good algebra from this point on, you're going to end up with an acceleration of 3.86 meters per second squared. And if you're not getting that value, you have an algebra mistake. You've done something like canceled m's that didn't cancel because there was not an m in every term. You need to make sure your calculator's in degrees, not radians. After you get your acceleration, solve for your t, which I don't remember what it was off the top of my head. Alright, so hopefully that helps. Make sure you've worked all the way through number 3 correctly.